This is the impact of artificial organs on organ failure patients. You might be wondering, why artificial organs? What are they? Well, for some background on this topic, with organ failure being the leading cause of death all over the world, there's a great demand for organ transplantation, but this demand exceeds availability. In 2019, there were over 113,000 people on the transplant waiting list, with only 36,528 transplants performed in 2018. Because of a donor shortage, there's a limited supply of organs that can be transplanted, and many people die while waiting. Figure 1 shows the staggering difference between the people that are waiting for an organ transplant and the transplants that are actually performed. There's a few reasons why only a few transplants end up being performed. Mainly, it is due to a donor shortage and the issue of the recipient's immune system rejecting the donor organ. Transplanted organs must be carefully matched to avoid transplant rejection. This is where the recipient's immune system destroys the foreign tissue. Immunosuppressants are taken to suppress immune response, but this leaves the patient vulnerable to other infections. These drugs are also expensive and must be taken for life, and they can cause serious side effects. Matched organs must also be the correct size and blood type for the body. The purpose of this study is to analyze artificial organ technology, determine its potential to save lives, and evaluate possible impacts on organ failure patients. For this study, a literature review was conducted on artificial organ technology and the impact it can have on people suffering from organ failure. So, what is an artificial organ? An artificial organ is something that works with living body tissues to replace or duplicate a specific function of an organ and is implanted into a human body. They don't necessarily have to consist of living tissue themselves, though. Artificial organs can be subdivided into 3 categories based on composition: mechanical, which is made from plastics or metals, such as a pacemaker; biomechanical, which is made from plastic, metal, and some living cells; and biological, which is also called bioartificial, which is made mostly or completely of living cells. Out of the 3 types of artificial organs identified, bioartificial organs offer the most promising solution to organ failure. Because this type is biological, it can offer a long-term replacement, contrasting the short-term solution offered by other treatments. The results of the literature review showed me that fully functional bioartificial organs offer a promising solution to the issues of donor shortage, matching organs to recipients, and transplant rejection. These organs can be created and used in transplants, solving organ donor shortage. Artificial organs could be made specifically for the patient's body and situation. Organs grown from the patient's own stem cells significantly reduce the risk of rejection because the organ will not be foreign. Artificial organs would provide an alternative to waiting for a compatible donor organ. At the bottom of the poster, there are 3 pictures that show the process of creating an artificial organ from the recipient's stem cells. This method for growing bioartificial organs out of stem cells was developed by Dr. Harold Ott in 2008. First, shown in the picture on the bottom left, a donor organ is decellularized by a pump that washes away the organ's unique cells. This leaves behind a structural scaffolding, shown in the bottom middle picture, that can be used to support the growth of a new organ. Second, the recipient's stem cells are grown into the type of cells needed by the organ being manufactured. Last, shown in the image on the bottom right, the cells are added to the base of the donor organ to repopulate it. This is then hooked up to a machine which pumps the organ as it would on its own in a healthy body. Organs created with this method are self-sufficient bioartificial organs made of living cells. The stem cell method of creating an organ from the patient's own cells results in an organ that will not be rejected and will not require the patient to be immunosuppressed. Although promising, this method is still being developed. It has been used to create organs that were transplanted into rats and pigs, However, the organs that were created from human stem cells did not survive for more than a week. Still, this shows that Dr. Ott and his team can create functional organs. If bioartificial organs become a reality, they could have significant impacts on organ transplantation and donation. Waiting time for transplants would be reduced, no waiting for a perfectly matched organ to be donated. After transplantation, the patient will not be required to take immunosuppressants for life. Currently, the prolonged use of immunosuppressants puts the patient at a risk due to their weakened immune function. In conclusion, the waiting list for organ transplants is continuously growing, and there is still a shortage of organs being donated. This presents a seemingly impossible problem. How can you transplant an organ into the people that need them the most if there aren't enough organs being donated? That's where the solution of bioartificial organs comes into play. The current unavailability of organs suitable for transplant makes artificial organs a viable solution for organ failure patients. Through artificial organs, people in need of a transplant would no longer be another name on the waiting list, but instead would become a life saved.